This is section 1.6 on number sense for Honors Algebra 1. Take a look at the top part, and the beginning of this seems so straightforward, right? How do you determine if one number has a higher value than another? Well, that's pretty easy when it's a nice, neat whole number, or if you have a positive or negative number, but it can get more involved, and that's when it becomes kind of more of a common sense thing. So notice the directions. It says insert one of these symbols. So notice this first one. Let's see here. This first one is a less than. All right, if I can get my pen to work, sorry. First one here is a less than. There we go, right? The second one is a greater than symbol. And then we have our equal symbol. Now, all right, sorry about the dogs in the background. So keep in mind on these less than and greater than symbols that it always points towards the smaller number. So on number 1, obviously 3 is a smaller number than 7. So notice it's going to point towards the 3. And that would be read 7 is greater than 3. If I go down to number 2, obviously 9 is less than 15. So it's going to point towards the 9. And that would be read 9 is less than 15. Okay, on decimals, it seems like it could be obvious, but when you see all those numbers kind of mixed up, to me, it's the smart thing to do is to start with the whole number. So the whole number here is 6. The whole number here is 62. So obviously, 6 is less than 62. You can do the same thing on number 4. Look at the whole number. This is a 2. This is a 1. So obviously, 2 is greater than 1. If we go over to number 5, I don't think it's any secret that 0 is going to be a lot less than 7, so it's going to point to the 0. On number 6, even though 2 is actually a higher number, right? Negatives are always smaller than positives, so I'm going to point to the negative 2. Negative 2 is definitely less than 1. On number 7, they're both negative. Now, I don't want you to have to draw a number line every time, but just kind of as a reminder, on a number line, if this is 0, right, the positives go this direction, the negatives go this direction, and the further you are to the left, the smaller the value. So since negative 1.2 is going to be farther to the left, here's negative 1.2, let's say, and negative 1.1. So it's kind of, negatives are kind of the opposite of positives. The higher the number, if it's negative, the actual value is smaller. So in this case, negative 1.2 is smaller than negative 1.1. Okay, are the following statements true or false? And again, this might seem obvious, but one thing I want to mention is if any part of the statement is false, then you have to say false. So if there's any way it could possibly be false, then it's false. So number 9, is 11 less than or equal to 11? Well, yes, it's equal to, so that's okay, right? So that would be a true. Is 4 greater than or equal to 7? Well, of course not. That's false. Is 10 greater than 11? Of course not. That's false. Number 12, is 3 plus 8 greater than 3 times 8? So you could think of that as 11 and 24. And of course not, 11 is not greater than 24. So I'm sorry. Yeah, so that is false. Number 13 is 8 times 8 less than 8 times 7. Well, of course, 8 times 8 has got to be more than 8 times 7. So that is false. Is 2 minus 3 equal to 3 minus 2? So in other words, if you have the same numbers and you subtract, are they equivalent? And well, no, because 2 minus 3 is negative 1, but 3 minus 2 is positive 1, right? That's not equal, so that's false. Okay. Letter A. Sometimes number sense comes about when you're talking about converting fractions and decimals and percents and so on. And I'm sure you learned back in your elementary school days, in order to change a fraction to a decimal, hopefully we all know that 1/2 is the same as 0.5. But the way we did that way back in the olden days was 1 over 2 is the same as saying 1 divided by 2. So it's like a 1 divided by 2. And remember, you can't divide 2 into 1, so you would put like a 0.0, and you bring that decimal straight up, and then you would say, oh, 2 goes into 10 5 times. And remember, that's how we actually did the division, okay? And then in order to change into a percent, remember what you do is you move your decimal place 2 times. So if I move it 2 times, the decimal would end here. Remember, in any empty spaces, you've put in a 0. So that means 0.5 is 50%. So 1/3, I think most of us, I mean, we could do the division, but most of us are familiar. 1/3 is 0.333, and it keeps on going. So one way we write that is to say 0.3, and remember that little bar means repeating, so it's 0.33333. And if we move the decimal 2 places to the right, we're going to get, if I move it 2 places, it's going to land right there. So we're going to say 33.3%, right? I know it keeps going, so I'm just going to cut it off after 1. 1/4, most people, recognize that as being 0.25. I always say, think of it like money, right? A fourth is the same as a quarter, and that's 0.25. 0.25, and if I move my decimal 2 places, that means it's going to be 25%. 1/5, again, you could divide it out if you want to, but 1/5 would be the same as 0.2. And if I move that decimal 2 places to the right, we're going to say 20%. 1/8 is probably less familiar than the previous ones. Again, if you divide it out, 1/8 is going to come out to be 125. And I wonder if this would make sense to you. Remember how we said 1/4 is 0.25? Well, if I wanted to, I could add a 0, right? I mean, 250 is the same as 25. And so think about it this way. Isn't 1/8 going to be half of 1/4? And isn't 125 half of 250? So I don't know, that might help you remember that one. And if I move that decimal 2 places to the right, it's going to be 12.5%. 1/10, I'm hoping that a lot of you remember 1/10 is just 0.1. Again, move it 2 places to the right, and that would be 10%. And then 1/100, 1/100th, you may recall, is 0.01, which, if you move it 2 places to the right, would be 1%. Okay, so percent is based out of 100, so 1/100 is 1%. Okay, now I expect you to know those. I mean, without having to pull up a calculator, I expect you to know those. And so if you know those, that's going to create a lot of number sense for you. So if I look at this, which one is larger? And this is all no calculator. So which fraction is larger? Is 2/3 or is 3/2? Well, this one might seem obvious because think about it. If the top number is smaller than the bottom number, that means the whole thing doesn't even equal 1 whole, right? 2/3 is less than 1 whole unit. But if the top number is more than the bottom number, right, 3/2, that means it's more than 1. So a fraction where the top number is smaller than the bottom is definitely less than a fraction where the top number is greater than the bottom. So in this case, if we're circling which fraction is larger, 3/2 is definitely larger than 1. We don't even have to think about it. I'm going down to number 2. So how do I know which is larger between 1/2 or 1/3 or 1 of any fraction? Something to think about. And again, I know I'm going way back to your elementary school days. Remember when you compared, look up here, when you compared fractions by cutting something up into pieces. So what you'll see here is this first design. I'm hoping you can see my cursor. I have a big giant box. So we're going to call the big giant box 1 whole. Well, here I've divided it up into 4 sections, right? So each section is 1/4. So I could say this square right, is equivalent to 1/4. But if you go over to the next box, the overall box is the same as the size of the first box, but this time I've divided it up into 6 sections. So one of these little sections would be 1 out of 6, would be 1/6. And hopefully you can tell the 1/4 box is definitely larger than the 1/6 box. And I could go one more way, and again, the third box, the overall box is the same size as the first two, and I divided it up into 9 pieces. So this little piece right here, since there are 9 of them, would represent 1/9. And isn't that one even smaller than the 1/6? So if we're just talking about fractions, the higher the number on the bottom, the smaller the unit, right? 1/9 is smaller than 1/6, which is smaller than 1/4. Now that's if we're only comparing one of them, 1/4, 1/6, 1/9. Okay, but keep that keep that in mind. Excuse me, sorry. Okay, so when I look at number 2, I'm comparing 1/2 and 1/3. Well, based on what we just said, the smaller the number on the bottom, the larger the value, and 1/2 is definitely larger than 1/3. I always also say, hey, think about money. Would you rather have a half of a dollar or a third of a dollar? Well, I'd rather have a half of a dollar. Number 3, which is larger, 4/5 or 2/9? There's a lot of different ways to think this through. When I see 4/5, I know that that's more than 1/2. Why? Because 4 is more than half of 5. But this one, 2/9, I know that that's less than 1/2. How do I know that? Because 2 is less than half of 9. So I know that 4/5 is definitely more than 2/9. Okay, let's go up here to the top, 1/4. Now this is a lot closer. I mean, 4/9, that's pretty close to a half. Why? Because 4 is close to being half of 9, but it's a little less than half, isn't it? So which is larger, 1/2 or 4/9? Well, 1/2, because 4 is less than half of 9. Okay, number 5. This one is a little more tricky. 7/10 or 3/4. Now, a lot of people might think of this as decimals. 7/10, if you look over here at our tenths, if 1/10 is 0.1, then 7/10 is 0.7. Look at the 3/4. Well, if 1/4 is 0.25, then 3 of those would be 0.75, right? Because 3/4 would be 75 cents. So now it's pretty easy to tell which one is larger. Well, 0.75 is definitely larger than the 0.7. Okay, which decimal is larger? Well, remember we said if you can just look at the whole numbers, great. But notice on all of these, the whole number is 0. So that means I have to look at the numbers to the right. Well, start comparing them one by one. So first we compare the first number, 0.2 to 0.2. Oh, that's the same. And notice 0.2, if there were another number here, it would be a 0. So now we're comparing 0 to 1, and definitely the 1 is larger. So on number 5, the first numbers are both 3, but now I'm comparing a 9 to a 0, so definitely 0.39 is larger. Okay, on number 6, the first numbers are both 9, but now I'm comparing a 2 to a 1, so the second one's definitely larger. Okay, which number is larger, 1/2 or 1/3? Well, if I know 1/2 is 0.5, doesn't that mean that that would be more than 0.3? Okay, what about 2/5? Well, remember up here we said that 1/5 is 0.2. That means 2 of those would be 0.4. I could say 4/5 would be 2, 4, 6, 8 would be 0.8. And so now, which is larger, 0.4 or 0.5? Well, definitely 0.5. What about 2/3? Well, remember, 0.5 is 1/2. Well, isn't 2/3 more than 1/2? So definitely 2/3. Okay, here's one that's a little bit closer. 2/5. Well, remember we said the fifths are 1 0.2, and we said that 2/5 would be like 0.4. So which is larger, 0.4 or 0.39? Well, definitely the 0.4. Okay, so that's just a little bit of getting started with number sense. And then the practice that we do for homework will kind of start with this and then take even a little bit further.